Day 250 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 250 of doing consecutive LeetCode problems daily, y'all. And we're making some progress, so I hope you've been keeping up with this channel. Today we have question number 909, snakes and ladders. The difficulty level's medium, but don't worry, we're going to keep the solution as simple and easy to understand for everybody, no matter where you are on your programming journey. So let's get into it. Now, I'm not going to really go through the question today. We're going to go straight to the examples because the question is kind of hard to understand in itself. It doesn't really make a lot of sense, even if you look at the example. So I'm going to just come to the example and explain to you what the question wants us to do and what the example is saying and what the game is that we're playing, right? So in example one, we have a board, right? So they're giving us a game that they want us to play. The game is represented by, it's a dice game. So we're rolling the dice to see how many moves we're supposed to move on the board, and we want to get from square one to square 36, right? So that's what this represents right here. Boom. This right here in the question represents, right here it says, the choice simulates the result of a standard six-sided dice roll, i.e. there are always at most 6 destinations regardless of the size of the board. So they want us to roll the dice, and the goal is to get from this square to this square. Now, it's important to keep in mind when we're writing our code that the board goes in sort of a zigzag pattern, right? So it goes from 1 to 6 right here, then we go up, it goes 7 to 12 this way, then it goes up, we go 13 to 18, 19 to 24, and so on and so on. And we need to keep that in mind when we're writing our code. Now, we also need to keep in mind the snakes and the ladders, hence the name of the game, right? So if we land on this 2, this ladder takes us straight to 15. And the object that we're trying to find out when answering this question is, what is the least amount of moves that we could take from going from square 1 to square 36, or from square 1 from square n to square n squared, right? So in this case, this right here in the input represents square 2, because square 2, say we land on square 2 will take us straight to 15. Boom. So that's why there's a 15 right here, and same right here. If we land, so the ladders will take us up and the snakes will take us backwards, right? So that's why if we land right here on 17, it's a 13 right here, because if we land on 17, it's going to take us to square 13. Also, if we land on square 14, it's going to take us, excuse me, y'all, this is square 14. If we land on square 14, the ladder is going to take us up to square 35. So the ladders will take us up, the snakes will take us backwards, and we want to find the least amount of moves to get us from here, point A, to point B, or from square n to square n squared, right? And in this example, the output is 4, because we could do this. We can move from square 1 to square 36 in 4 moves, right? So let's look at the explanation so we can make it make sense. In the explanation, it says, in the beginning, you start at square 1 at row 5, column 0, right? So that's right here. Row 5, row 5, column 0. Boom. So we start right here. We could go one move when it says you decide to move to square 2 and must take the ladder to square 15. So we go right here, boom, to square 2. That takes us straight to 15. That's one move already. We're already at square 15 in one move, right? Because of thanks to this ladder. Now, another thing to keep in mind is we cannot use 2 ladders on one row, and we cannot use a ladder and a snake on one row. So even though we landed on 15 and there's a snake right here, we still have to wait till our next row and see where that takes us before we go to 13. We don't just go from 15 to 13 in one move. We have to wait until our next row. So right now we used one move, we went to 2, and that took us to 15 in one move, right? Then it says you decide to move to square 13 and must take that to square 13, right? So we're going to move the square 17. Boom, that's one move. We're going from 15 to 17. That's our one move, but 17 takes us to 13. So we go from 15 to 13 in one move, right? Because we went from 15, landed on 17. 17 takes us all the way back to 13. So now we're two moves in and we're on 13. Boom. Then it says you decide to move the square 14 and must take the ladder up to 35. So this is our third move, right? We're on 13, we move to 14, but 14 takes us all the way to 35, and we're only on move 3, and now we are at square 35 in 3 moves. Then it says you then decide to move to square 36, ending the game. So we have one more move from 35 to 36 so we can end the game, and we did all that in 4 moves. Explanation says the lowest possible number of moves to reach the last square, so we return 4. This is the lowest possible number of moves, so we return 4. We got from square 1 to square 36 in 4 moves. That's the lowest possible amount of moves that we can do in order to win the game. That's why the output is 4. We just want the lowest amount, whatever that is. And in this case, with this board, the output is 4. So that's what the question is asking. That's what they want us to do. Keep in mind of the parameters that we need to remember, such as we can't use 2 ladders in one move or a ladder and a snake in one move. We have to wait to the next row. And when we're coding this, we also have to remember that the board moves in a zigzag type pattern, right? So that's why we have to keep that in mind as we're coding our solution as well. Now that we understand the solution, though, let's get into the fun part, the actual code. But before we get into the code, y'all, if you guys need any new Apple AirPods, don't forget to go check out the link in the description. Then after you do that, don't forget to like, comment, and subscribe, y'all. Now let's get into this good old Swift code that we know and love, right? So first thing we need to do is we need to create our constants and our variables, right? So first thing we're going to do is create a constant called n. We're going to say let n equal board dot count. And this is just the size of the board, the number of rows and columns, because remember, it's up here, it's a n by n matrix, integer matrix. So n is going to be the same and the board is going to be a square, right? So we're going to set let n equal to board dot count, and that's just going to help us get the size of the board. Then we're going to declare a variable. We'll call this one hm, and we'll set that equal to a dictionary. So open up the square brackets, integer, colon, integer. So dictionary of integers, come outside of that. We're going to initialize it with 2 parentheses, and this is going to store the mapping, the board mapping, right? So the cell and the destination. Then we need to come down here and we're going to declare another variable called start, and we'll set that equal to n times n. And that is going to start at the last cell of the board, or the top left for us, right? In this case, it started at the top left for us. Now, that's the n. That's the same thing as n squared, right? So n squared. This is the same thing as n squared. Boom. Because remember how the board is moving, y'all, right? The board starts here, boom, 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 like a zigzag, right? So we're going to start at n squared. Now it's time to map the board, and we need to remember to handle the alternating row directions as we do that. So when we do that, we're going to say for I n, n, not letter n, I n, for I n 0 up to n. We're going to open up the brackets. Then for I, that should be a 0. Then we're going to do the same thing for j. We're going to say for j n 0 up to n. Open up the brackets. Now we need to check if the row is odd or even, right? To know if we are which direction we're going in, right? So the even rows are going to go from left to right, and the odd rows are going to go from right to left. So we need to handle that here. So this is how we're going to handle that. We're going to say if open up the parentheses, n. Open up some more parentheses too. So 2 parentheses, then we're going to say n minus I. Come outside the first set of parentheses, but still inside the parentheses, we're going to say mod 2 equals 0. Because remember, we're trying to get the odd and even. This is going to get us the odd or even, right? Then we're going to say if open up the brackets, then we're going to say HM, open up the square brackets, start, come outside the square bracket, say equal, board, square bracket I, square bracket J. And this is the even rows going from left to right. Then we're going to say else, open up the brackets, we're going to say HM, square bracket, start, come outside the square brackets, equals, board, square brackets, I, come outside those square brackets. Then we're going to say square brackets, N minus J minus 1. And that's going to be the odd rows that move from right to left. Then come outside of that, outside the else, and we're just going to say start minus equals 1, and that's going to move to the previous cell, right, in the 1D representation. So we had to convert it to a 1D representation, and this is going to move to the previous cell in our 1D representation. Now we're going to come down here outside of the for loop. Now we're going to create another variable called Q. We're going to use some breadth first search with a B, breadth first search. So we're going to declare a variable called Q, and we're going to set that equal to an array of integers. Come outside of that, put the parentheses. Then we're going to declare another variable called HS, and we're going to set that equal to a set of integers. So set less than int greater than parentheses. Then we're going to say we're going to start our breadth from search from cell 1. So in order to do that, we're going to say Q dot append square bracket 1. Then we're going to come underneath that, and we need to mark cell 1. We need to mark cell 1 as visited. So we need to know that we visited cell 1. So in order to do that, so we don't revisit it, we're going to say HS equals insert, open up the parentheses 1. Then we need a way to count the number of steps that we take or the number of moves we've made, right? So in order to do that, we're just going to create a variable, say var step. We're going to set that equal to 0 to start. Now it's time to perform our breadth first search to find the shortest path to the last cell, right? So let's get into that. So when we do that, first thing we are going to do, we're going to use a while loop. We're going to say while exclamation point Q is empty, which means while it's not empty. That's what that exclamation point means. We are going to say, we're going to open up the brackets. We are going to say let size equal Q dot count, and that's the number of nodes to process at the current level, right? So then we want to start our for loop. We're going to say for underscore 0 n, not underscore 0, for underscore n 0 up to size, open up the brackets. We're going to say let current equal Q dot remove first, put the parentheses, and that's going to get the next cell for us to process. Then we're going to say if parentheses current is equal to n times n, so n squared, n times n, meaning if we reach the last cell, then we're going to come outside of that, we're going to open up the brackets, and we're going to return step, right? We're going to return the number of steps that it took for us to get there. Now we're going to come underneath that, still inside the for loop, but underneath that if statement, and we are going to say for j in 1 through 6, 1 dot 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 6, which is gonna represent our dice roll. We're gonna declare a variable called new point. Let me see, new point. We're gonna set that equal to current plus j, and that's gonna move to the new cell. Now we're gonna come underneath that. We're gonna say if, open up the parentheses, new point is greater than n times n, then what we are going to do is we are going to, let me see. So if the new point is greater than the board itself, then we're just going to skip it. So we could just open up the brackets and say continue, just like that. Then we're going to come underneath that if statement. We're going to start another if statement. We're going to say if, open up the parentheses, hm, open up the square brackets, new point, come outside the square bracket, still in the parentheses though, exclamation point equals to not equal -1, right? Then we're gonna say, so this is if the cell has a snake or a ladder, what we are gonna do, because remember all of the whole board equals -1 except for the cells or the squares that have a snake or a ladder. So with this saying, if we reach one of these cells that has a snake or a ladder, we need to move to that destination cell. So we're just going to say new point equals hm square brackets new point, new point. Come outside of that, we could just put an exclamation point to force unwrap it. Now we still got another if statement, so we're going to come outside this if statement. We're going to say if, open up the parentheses, exclamation point, hs dot contains, open up the parentheses, new point. So if the cell hasn't been visited yet, we need to add it to the queue and mark it as visited. So we just come outside of this, open up the brackets, and we are going to say q dot append the new point, parentheses, new point. Then we need to mark it as visited, so we're going to say hs dot insert, open up the parentheses, new point, just like that. Now we need to come down here and we need, to increment the step count after processing one level, right? So in order to do that, we'll just say step plus equals 1. And then we need to, if the last cell is unreachable, we just need to handle that case, and we could just say return -1, just like so. Now I know that was a lot, y'all. Let's run it. Hopefully it runs first try. Let's see. Okay, we got a typo. Line 14. Oh, sorry, y'all. Should be a space right there. Let's run it again. See what happens this time. Okay, type has no subscript. So let's see. Now let's see what we need. What's going on here, right? So this, my bad, y'all. This should be parentheses. My bad. Now let's run it again. See what other errors they got for us. Hopefully none. Oh, and it's accepted, y'all. 0 milliseconds. So let's submit it. Make sure it stays accepted after we submit it, because we all know how this LeetCode stuff could get on us. Let's see. Ooh, 12 milliseconds beats 13.33% of users with Swift, y'all. Don't worry about those numbers right now. We just want to be able to solve the problem that's presented to us, y'all. And we need to be able to understand the solution while we're learning so that we'll be able to apply that knowledge for future problems, y'all. If we go through a solution and we don't understand it, that means we're not going to be able to apply what we learned on the next problem, because that means we didn't learn anything, y'all, and that's not what we want. So that's why we're not really worried about the time complexity right now. We're just worried about finding solutions that we can understand and learn from, and I feel like this is a good solution for that. So before we leave, y'all, make sure you get one more look at the code. One more look at the code, y'all. I know it's a lot. It was a lot of code today, but make sure y'all read it, learn it, love it, internalize it, understand what's going on and what's happening with the code so that you can apply that knowledge later on, y'all. And I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.